Hello. Today we discuss the placing of elements in the modern periodic table. We all know that there are 118 elements in the modern periodic table, and those 118 elements are placed in different periods and different groups. There are 18 groups and 7 periods in the modern periodic table, and the elements are placed in the modern periodic table according to their electronic configuration. Therefore, the electronic configuration of the elements is called as backbone of modern periodic table. The electronic configuration is called as backbone of modern periodic table. See here, now how to place the elements in the modern periodic table in different groups and different periods. This is learn by using these two methods, and here this is the unofficial method and this is the official method to place the elements in different periods and groups. See here, this method 1 tells that if the last, here this is the electronic configuration, that is valence shell electronic configuration. Valence shell means the last shell electronic configuration, and here VE is valence electron, the electrons present in the valence shell, and here this is the group number. There are 18 groups, 1 to 18. Now, if valence shell configuration is ns1, here only one electron is present, that is valence electrons are 1, which means that it belongs to group 1. If the electronic configuration, valence shell electronic configuration is ns2, then valence electrons are 2, therefore it belongs to group 2. This is for S block elements. And here, this from D1 to D10, this is for D block elements, because D occupies maximum of 10 electrons, that is D1 to D10. If the valence shell configuration is n-1 D1 ns2, see here the valence electrons are 2 plus 1 is 3. Therefore, it belongs to group 3. D2 ns2, 4 valence electrons, group 4. D3 ns2, 5 valence electrons, group 5. D5 ns1, group 6, because it contains for 6 valence electrons. Similarly, D7 ns2, 9 valence electrons, group 9. And this is for D block elements. For P block elements, ns2 np1. See here, the valence electrons are in S, 2 electrons, P, 1 electrons, which means that 3 valence electrons, group 13. For P, here, ns2 np2, which means that here 4 valence electron, 14th group. Similarly, ns2 np6, there are 8 valence electrons and it belongs to group 18. This is the official method. And this is the unofficial method. Here, if S orbital is there, that is the valence shell electronic configuration contains last S orbital, then take it as it is. I'll take by example, then you come to know. Here, if it contains, that is the valence shell electronic configuration contains p orbital, then add +2 to the last electrons. If it contains d orbital in valence shell, then add +2 to that number. Now, learn this by using examples. First, we take example. Carbon. Carbon, it is having the atomic number 6 and the electronic configuration we write 1s2, 2s2, 2p2. See here, this is the valence shell configuration, which means that the last shell configuration. Here, how to calculate the group number, which means that the largest orbit or shell indicates the period. It indicates the period. Here, largest orbit is 2, which means that the period, it belongs to period 2. And see here, in a valence shell configuration, the largest orbital contains the electron number is 2, which means if the p orbital is there, then add +12, which means that 2 plus 12 is equal to 14, which means that this indicates the group number, which means that carbon belongs to second period and 14th group. See here, in official method, the last shell configuration is ns2 np2. Here 2s2 means ns2 np2. See here, ns2 np2, which means that it belongs to 14th group. Clear? Which means that like this you have to calculate the period number and group number. Another example we take oxygen. Atomic number is 8. Then write the electronic configuration 1s2, 2s2, 2p4. Here, this is the valence shell configuration, and the largest orbit is 2. That orbit indicates the period number, that is oxygen belongs to second period. And here, the orbital contains 4 electrons. If p orbital is there, then add +12. That is 4 plus 12 is equal to 16. It indicates the group number. Oxygen belongs to 16th group and second period. If you see the official method, here valence shell configuration is ns2 np4, ns2 np4. See here, ns2 np4, 16th group. Here also you get 16th group, here also you get 16th group. Now another example we take. if you take aluminium as an example, it is having the atomic number 13. Write the electronic configuration 1s2, 2s2, 2p6, 3s2, 3s2, 3p1, 6, 8, 10, 12, 13. See here, valence shell configuration contains the highest orbit is 3, which means that this 3 indicates the period number. And how to calculate the group? This valence shell contains the subshell, that is P contains 1 electron. If P orbital is there, then add plus 12. Here 1 plus 12 is equal to 13. Here 13 is the group number. Aluminium belongs to third period and 13th group. See here in this, here Ns2 Np1, Ns2 Np1, which means that aluminium belongs to 13th group. Here also you will get 13th group. And another example, argon. If you take argon, it is having the atomic number 18. Then if you write the electronic configuration, write 1s2, 2s2, 2p6, 3s2, 3p6. See here, valence shell configuration. It contains highest orbit is 3. It is period number, and the orbital contains 6 electron. If p orbital is there, then add plus 12. Or see here, Ns2 Np6, Ns2 Np6, 18th group. How you get 18th group? See here, the valence shell electronic configuration is Ns2 Np6. Therefore, Ns2 Np6, it belongs to 18th group. See here, if you add plus 12, 6 plus 12 is equal to 18, which means that 18 is the group number. 18 is the group number. Like this, you have to calculate the number of group, that is the group number and period number. Last example we take. Last example is, if you take calcium as the example, calcium 20, atomic number is 20. If you write the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 6, 8, 10, 16, 18, 20. See here, valence shell contains 4th orbit. This 4 indicates what? The period number, which means that calcium belongs to 4th period. And here the subshell or the orbital contains s orbital. If s orbital is there, then take it as it is, which means that here it is belongs to 2nd period. Or see here, Ns2. See here, Ns2 means 2nd group. Ns2 2nd group. If s orbital is there, then take it as it is. Here it belongs to 2nd group and 4th period. Calcium belongs to 2nd group and 4th period in the modern periodic table. Here you try by taking another example, then you come to know how to place the elements in modern periodic table. This is the method to place the elements in modern periodic table.